Alright guys, we are going to be going over 6.8-3. So I've already written some stuff because my computer crashed halfway through the recording. So I'm just going to leave up some of the base work that I had set up. Okay, so in this problem, in part A at least, they're asking for based on centerline dimensions. So this is an approximation method that is learned in section 8 of chapter 6. So the basis of this is that your h value, as you can see here, is going to the center line of your flanges for the I-beam, okay? And all we're going to do is, all it is just a easier, more approximation-based method, and we're going to compare the two from part A and part B to see, okay, what does the approximation method give you as opposed to the exact method as learned in chapter 5 that you guys did a while back. Okay, so as you can see, I've already set up the shear equation that's given in the chapter and the inertia equation. So if we solve this equation, we are going to get an inertia of 11.21, okay? And then that, once you plug it into this equation, will give you, I'm just going to write out the equation just to make sure that you guys understand all the parts. So this is for shear, using the equation above. I'm just going to write everything out just to make sure that everything makes sense. 0.285 465 plus 4, okay, multiplied by our P, and I wrote it up here. P is just our shear force. It's just a way that they write it in the book. And that's 5 times 10 to the third because we are in kilo, so we're converting everything to the base units. Gotta make sure you have that. 0.06 over 2.1. Okay, so this is our setup. And once you put all those things in the calculator, create a new layer, you are going to get a shear for part A, and that shear is going to be 7.5. Is that okay? So now what we're going to do is we are going to look at part B. Okay, so these are calculations based on the exact method learned in chapter 5. I'm just going to be drawing the equations out from chapter 5. Here is the diagram. This is just showing how they solve it. So they use H1 and H for this, and then their T is just the T of the web. Okay, so just gonna start by writing out our shear equation for this, and that's found in chapter 5. So it's V over 8 IT, and this inertia is different than the one that we saw before. Oops. And it's that times we got BH cubed. That is actually squared. Don't know what happened there. Minus B H1 squared plus TH4. Sorry, my computer is a bit glitchy today. 1 squared. Okay. So we got that. Now, see if I can write the inertia equation a little better, hopefully. So that is 12 times BH cubed minus B h1 cubed. Okay, so if you solve this guy, your inertia is going to come out as 109.29. And if you solve for your shear, once again, it's just plugging in the numbers from before, reminding that that is how you get h1 from the values that you've been given before. And then they, in this problem, say h is equal to h2, right? Because, once again, we're just trying to find that distance right there. Okay, so once you plug in all of those values, you're going to get a value of 3.7 psi. Okay, so now we can see that if we go back to here, part A is what we got for this, and the shear in part B is 3.7 psi. So you do see that there is a slight difference between the approximation and the exact method. So we can see that A is a overestimation from the exact value, right? And that is how you solve this problem. Thank you for watching.